Good evening. Tonight's lesson is on combining like terms. Okay, before we can start talking about combining like terms, we have to understand what it means to be a term. And in algebra, a term is any number, variable, or numbers multiplied by variables. Okay, and what like terms are is any term with the same variables to the same powers. Okay, so in my first example here, my problem is x squared y to the fourth z to the seventh plus 3x squared y to the fourth z to the seventh. And the first thing we have to understand is, are they like terms? Okay, so do they have the same variables? X, y, z, x, y, z. Yes, they do. And then we check to see that those variables have the same power. So the power on the x is 2, the power on this x is 2, the power on y is 4, the power on this y is 4, and the power on z is 7, and the power on this z is 7. So are they like terms? Yes, they are. All the variables match, all of their powers match. Now the number in front is like a coefficient. It is what you add together when you combine like terms. So we don't have to have the same numbers, just the same variables to the same powers. Okay, so the answer is yes. These are like terms. They have the same variables, the same powers. And can we simplify this? Yes. If there are like terms that are being added together, then we can simplify. Okay. In math, we like to condense things as much as possible because having this problem as it is, so having this as it is complicated, right? It's complex. I can simplify it. I can condense this. So what I'm going to do is take the problem, and you take the variables, keep them the way they are, so x squared y to the fourth z to the seventh, and then you add the numbers out front. So this, I have 1 of these here and 3 of these here. So if I add them together, I have 4. So 1 plus 3 is 4. So I've condensed this term into a single term, 4x squared y to the fourth z to the seventh. So it's less complex, it's less writing, and now it is as simplified as it can get. Okay, so for example, for these types of problems, we've come up with something called the rule of shapes. Okay, so for every like term that you can identify, I put a different shape on it. So in this problem, I have 3x squared minus 5x plus 4y minus 5y squared plus 6x squared minus 3y. So I'm going to go through and identify like terms, first starting from left to right. So are there any other x squares? I'm going to make this a square. Okay, there's one other x squared, it's 6x squared. And the important thing is with the rule of shapes is that you keep the sign, so both of these are positive squares, right? Now, next variable over is an x. There are no other x's in this problem, so it's by itself. I'm going to use a circle. Like I said, keep the sign with the problem. So these are positive, this one's negative. Right? Now I'll check for y's, so I'm going to use triangles for this one. It's positive 4y, and here at the end of the problem I have negative 3y. Okay. And then negative 5y squared is all by itself, so I'm going to use an upside down triangle for this one. Okay. And we kind of can think about it as having a set of things. I have 3x squareds, I have 6x squareds over here, so 3 plus 6 is 9x squared. Okay, I have negative 5x here, but there's no other x, so I'm just going to rewrite that. I can't add anything to it. There's nothing to simplify. I have 2 triangles. I've got 4 triangles here and negative 3 triangles here. So 4 plus negative 3 is 1y. Okay, so we take out what we can. Now, there is no other 5y squared, so I would just have to rewrite that, minus 5y squared, and that is as simple as it gets. Okay, so you have to be able to identify, are these like terms? So negative 6 and 5, they're numbers, so numbers are automatically like terms. As long as they don't have variables, these are like terms, so yes. Okay, if I've got 8x and 7y, the numbers are fine, but the variables are different, so these are not like terms. So no, because this is x and this is y. Okay, 7x squared and then negative 6x squared, despite them being positive and negative, they both still have the same variable, x to the same power 2, so yes, they are like terms. Okay, 9 and 4x, these are not like terms. The 9 over here does not have a variable at all, and this one has an x, so this is no, they are not like terms. Okay, 3x and negative 4x, okay, they both have an x. Despite the numbers being different signs, they are still like terms. The same x, same power. Yes. Okay, and then number 6, negative 9x squared and 4x. Okay, this has an x to the second power, and this has an x to the first power, or no power. So that means these are not like terms. They're different. They're the same variable, but different powers. So no, these are not like terms. Okay, so for example, I want to move on and do some practice. Okay, so in this first problem up here, starting with 5, I want to check and see if there are any other numbers in this problem without variables. This one doesn't have variables, so any like terms would be without a variable. I'm going to go ahead and circle it, put a circle around it. Okay, and remember, keep the signs. So there is one other one without variables, it's the positive 1. So I'm going to put those together, get 5 plus 1, which turns out to be 6. Then check for x's. I'm going to put square around the negative 2x. And there is no other x in this problem. Both of these have squareds. So it's just negative 2x. I'm going to rewrite that. Okay, and then for 3x squared, I'll just go ahead and use a triangle. Okay, and so I've got a negative 2x squared here to go with the 3x squared. Put them together, and this is another way that you can do this more visually, right? You can put them together in groupings and then add them together. So I've got 3x squared minus 2x squared in a group. And what happens? I got 3x squared minus 2x squared gives me 1x squared. So I've got the negative 2x that comes down. 3 minus 2x squared is 1x squared. Okay, and since there are no other matching like terms, that means that this is my final answer. It's as simplified as it gets. Okay, and that's my goal. I want to condense it. The last thing you want to do is try to solve these. There's no reason to. There's no equal sign, right? That's the biggest mistake I see. No one should try to solve this. You're just simplifying. Get it as condensed as you can. All right, in our last example, I've got starting with 6x, I have a 6x here, and another x on the negative 2. So those are like terms, 6x and negative 2x. And I'm going to circle my y, so it's positive 10y, and there's a negative 5y over here. And then finally, I've got the positive 3, but there's no other numbers, so that's out there by itself. So, okay, so I'm going to group my like terms, 6x minus 2x, then my positive 10y, and negative 5y, and then out here by itself is positive 3. So group them together, 6x minus 2x is 4x. Okay, and remember, you're just adding or subtracting the numbers in front. You keep the variable, so x stays the same. I've got 4x. Keep my variable y. I get 10 minus 5 is positive 5, and then positive 3 is all by itself, so that just comes down at the end. And that is as simple as it gets, because x and y are not the same variable, so I cannot add them together. Okay. On your own, I want you to try the 6 practice problems at the bottom of the page for tomorrow's lesson. Have a good night. Please make sure you email me any questions you might have.